This is Marvel's Spider-Man, with players step into the shoes of the iconic web-slinger swinging through the bustling streets of New York, defending its citizens from all manner of threats. At the 2019 GDC, Insomnia Games gave a presentation on the AI of Marvel's Spider-Man. The AI implementation is a mix between behavior trees and finite state machine. In Unreal Engine, we can build similar AI using State Tree. State Tree was introduced in Unreal Engine 5 and first seen in action controlling the pedestrians in the city sample. Playing Marvel Spider-Man, the AI seems so simple, yet recreating the same AI in your own game always end up being hard. In this video, I'm going to share with you how to recreate parts of the AI in Marvel Spider-Man as shown at the GDC presentation, using Unreal Engine and State Tree. At the end of this video, you will be able to implement Game AI using State Tree and expand on the functionality introduced in this video. In order to create the AI behavior, some foundation work is required. The following plugins are required to implement State Tree. Changes to plugins will require a restart. First up is the interface used to retrieve and send data to the NPC character. Using an interface simplifies communication with the NPC character, as there is no casting required whenever data needs to be retrieved or sent. Next is an enumerator that indicates the state of the NPC character based on perception. Implement the interface on the NPC character and add the perception enumerator as a variable. AI behavior consists of different tasks. Each task will be represented as a value in the behavior enumerator. The NPC behavior can either be scripted or default. This will be represented in a run state enumerator. Tasks may require data. Using a struct makes implementation easy as the property signature for each task is the same. The controller is responsible for the behavior of the NPC character. This makes it the best place to implement all behavior-related support functions and variables. The state tree manages all the AI logic. The logic is represented as states. Each state has conditions for entry, tasks to execute, and transition logic when done. Managing these states are done in one or more evaluators. The NPC will have the following behavior tasks. Focus on player to set NPC focus on the player character. Idle to do nothing. Move to location to move the NPC to a set destination. In the state tree, change the context actor class to the NPC controller blueprint class, as the state tree is hosted in the controller. The context actor is referenced by evaluators and tasks. Once this is done, the different states can be added. First state will be the behavior state. This will be the parent state for all the different behaviors the NPC can do. First behavior state is move to location. This will have an enter condition for current behavior of move to, execute task move to location, and transition to next on completion. Repeat the same for all the other behaviors. Set the condition for the appropriate behavior. Select the relevant task and set transition on completion. The GDC presentation starts with scripted behavior. The inner workings of the scripted behavior is explained with C++ code examples. This is then followed with a visual example which shows the script and behavior result. In this in-game example, we have Miles fight escaped prisoners, a police car arriving on the scene and wait for it, Rhino running through the scene with Spider-Man trying to stop him. Rhino running through the in-game fight scene is an example of scripted behavior. Implementing scripted behavior requires some additional changes. Add a request control function on the controller. This function will verify if it's safe to allow scripted behavior to run. Create a scripted behavior evaluator. This manages the run state on the controller based on the script queue. When new behavior is added to the script queue, the evaluator will request control from the controller. If control is given, the run state will change to scripted. Create a run scripted task. This will execute the next behavior in the queue. On the state tree, change the behavior state to transition to next. Add a scripted state, add a run scripted behavior child state. Set the enter condition, add the run scripted task, and set the transition on done. Add a done child state to scripted, which will act as the default state. Fix the transition logics for behaviors. Set idle to return to parent when done. Add the scripted behavior evaluator to the state tree. Update the parameters of the run scripted task to use the output of the scripted behavior evaluator. Compile and verify all is okay. In the NPC character blueprint, add the add scripted task event to add new behavior to the scripted queue. On the begin play event of the level, scripted tasks are added for the first NPC. Scripted tasks for the second NPC are added on the trigger placed in the level. These will only execute if the player moves through the trigger. When the level starts, the first NPC moves to the scripted location and focuses on the player. Once the scripted behavior is done, the NPC falls back to default behavior and repositions close to the player character perceived. Most of the NPC combat in Marvel's Spider-Man consists of action combos. Insomniac Games used a data-centric approach. This made implementation of all the different combos used by all the different AI classes easy. The presentation included C++ examples while stepping through the tree logic, which was then followed by a visual example of execution. In Unreal Engine, the same data-centric approach will be implemented. Combo Move Melee, Combo Move Container, and Combo Move Entry will all be blueprint structs, while Combo Config will be a custom data asset. Once all this is done, a Melee combo data asset can be created containing all the different Melee combos. In the NPC controller, create a is close to player function. This function will check if the player is in range to execute a combo. Then create a get combo function. This function will select the best combo based on the current distance to the player. Create a use combo state tree task, which will execute the selected combo. Create a default behavior evaluator. This evaluator is responsible to manage NPC behavior based on perception. Add the default behavior evaluator to the state tree. Add a Melee child state to the behavior state. Set this enter condition, select the use combo task to execute, and set the transition on done. Here is an example of the NPC executing a combo selected on the current range to the player character. All combat is controlled using managers. Marvel Spider-Man has one manager for melee and one for ranged combat. These two managers will coordinate the combat when needed, but mostly they work independent. Without any managers, combat will just be chaos that the player will need to navigate. The melee manager started out simple. It would assign one attack job with priority. Priority is based on NPC waiting time, distance, and NPC priority. As development of the Melee Manager continued and more user testing done, the end result had way more parameters than it started with. The Range Manager also started out simple. It had an attack and cooldown window. After some user testing, some more parameters was added. More user testing was done and then some more parameters was added. Finally, the Range Manager ended up with more parameters than initially planned for. In this example, a Melee Manager is implemented in a custom game instance. The game instance has a request to attack event, which will apply a cooldown to the requesting NPC and increment the attack counter. It will not allow more than a maximum number of attackers. In the game instance is also a attack done event, which will decrement the attack counter. In the use combo task, a request to attack will be sent to the game instance. If allowed, the attack will continue. Once the attack is done, the game instance will be notified. The last item covered from this presentation by Insomniac Games is how NPCs are positioned around the player. Creating the ideal positioning system is most of the time a challenging undertaking. Not only does it have to take into account the play space, but also the actions of the player. In Marvel's Spider-Man, Insomniac Games also had to try different methods to best position NPCs around the player character. They started with 2 rings that contained position slots, but that didn't work. They tried gradient descent hill climbing, but that did not work either. In the end, they returned to a simpler implementation of the rings they started with. EQS is the spatial query system in Unreal Engine. This allows for simple to complex spatial queries to position NPCs. Create a EQS context named last known location context, which will return the last position the player was spotted. Create a EQS named last known location query, which will create a donut around the last known location context, preferring locations closer to the context and does not have a trace hit on the camera channel. Once implemented, the NPCs will arrange around the player evenly spaced. That is it for this video. Thank you for watching. See you in the next video.